Morning, class. Today's lesson is going to be about how to transfer a distance time graph to a velocity time graph, and I'm going to try to do this in 5 minutes or less. So let's get started. So hopefully you have your notebook open to the next blank page. Let's put a title up at the top. This is going to be dt, distance time, to vt, velocity time graphs. And the first thing I want after the title is a list of quick cheats that we're going to have in place so that we can quickly refer to them as needed. Let's make a t-chart, and on the left side let's put dt, and on the right side let's put vt. And I'm going to go through about 4 different basic shapes and show you how they translate from one to another. The first shape is going to be an acceleration line. So in the distance time graph, if we have a curved line curving upward, that tells us that the object is accelerating to the right. On a v time graph, that would look something like this, where the curved line just becomes straight, because straight means that we are accelerating at a constant rate, or the velocity is steadily increasing. Okay, here's our second cheat. In a distance time graph, if you have a straight line moving up to the right, that tells you that the object is moving at a constant speed, constant velocity to the right. And on our velocity time graph, that would look like a straight line in the positive region of the graph. Constant velocity on a VT graph. Next cheat, in a distance time graph, if you have a straight flat line, that tells you that the object is not moving, so the velocity would be 0. On a velocity time graph, we would do something like this. We'd have a 0 line, and we would have a line, flat line at 0, showing 0 velocity. And here's our last cheat. And that's going to be what happens if we have a line that goes down and to the left. Well, that shows that the object has a constant velocity to the left, or a negative velocity. And on a velocity time graph, we might draw it something like this, where we have a 0 line, and then we would have a straight line down in the negative region of the graph. Okay, let's do a quick example. On the left side of your notebook, copy this dt graph, and on this dt graph you notice that it's broken up into 3 parts. There's 3 motions here. The first motion is up to the right, which is constant velocity to the right, positive. Then there's a motion to the left, negative, constant velocity, and then last segment is a slower constant velocity to the right. What would that look like on our VT graph? Let me show you. Okay, the first segment on the left is a positive velocity, so let's put a line in for constant positive velocity. The second segment shows a constant negative velocity. Let's put a line in for that. And then the third line is a constant positive velocity, but not quite as much as the first one. So let's do this, connect these with lines, and we get something like that. So pause this video if I'm going too fast, but we need to move on to our last example here. Here's our distance time graph, and you'll see that it has 3 segments again. The first segment is an acceleration to the right, then we have a constant velocity to the right, and finally we have a stop. What would that look like in our velocity time graph? Let's break it down into the 3 parts. The first part on the dt graph is that upward acceleration, and on a velocity time graph that's going to be shown as a straight line with the positive slope. The second line on the dt is that velocity to the positive velocity, constant positive velocity, that's going to be shown with a straight line there on our velocity time graph. And the last segment on dt is staying still, and we're going to drop down and show 0 velocity there. And I want to say thanks for watching. Have a great day.